Okay. So if a device wants to communicate on the network, it requires an IP address and a MAC address. So MAC address is already there, and IP address we have to assign. Now some people,
even format the laptop, MAC address will not change, right?
no, MAC address will not change. If the adapter goes bad, it will change. If you change the network adapter, it will change. Okay. Now, so if a device on the network wants to communicate, it requires an IP address, internet protocol address, and a MAC address. So some people in the interviews, they ask, why can't we use only MAC addresses and why do we require IP addresses? IP addresses are decimal numbers and it is easy to manage, you can say. Let's say, what is an IP address? IP address is a 32-bit address. It is written in decimal format and separated by dots. Separated by dots. Always use the word term dots. In my class, I see some freshers, they call it a point. It is not a correct term. You should call it a dot. So an IP address is of 32 bits and it is written in octal format. Octal means you have 8 bits in an octet. As we have seen, 1 is a bit and 4 is a nibble and 8 is an octet. So IP address is written in 4 octets. 1 2 3 4 5 6 7 8 and 1 2 3 4 5 6 7 8. Yeah, I think here I have 4. Yeah, correct. So an IP address is of 32 bits. It is written in decimal format and separated by dots. Now, if you see the whole octet, every bit has a power of 2. So if you say what will be the total value of one octet, the total value of one octet will be 2 raised to the power of 2. 2 raised to the power of 2, and usually we start from this bit. We start from this bit and we start counting over here inside. And you can say like that. So every bit over here, so the first bit here will have a power of 2. So this is the first bit. So this. So how many? 2 raised to the power of 8, right? 2 raised to the power of 8. The maximum value of this is 256. So we start with 0 and the last number is 255. So in one octet, you will see any number that is from 0 to 255. So like this, we have 4 octets, 0.0.0.0 starting, and the last number is 255, 255, 255.255. In any octet, in any network, there are always 2 addresses that are reserved. One is the first address and one is the last address. Now, technically, this 000 is reserved for some other purpose, and 255 is your broadcast address. Once we see DHCP, then we will come to know, okay, that 0.0.0.0 is reserved for DHCP request, you can say. But we will see later on. DHCP has a process: discover, offer, request, acknowledge. When he does discover, the device does not have an IP address. At that time, he uses this address as a source address. We'll discuss about that later on. No problem. So in every bit, you can see a number from 1 to 255 because usually we don't start in the network part with 1. Now, IP addresses, 32-bit addresses have a format for 2 devices to communicate. Now there are classes actually. There are classes class A, class B, class C, class D, and class E. And again, there are 2 types of addresses also. One is a public address. And one is a private address. So there are 2 types of addresses. You can say technically 3 types. One is a public address, one is a private address, and one is, you can say, a special address that we cannot use. We'll discuss what is a special address. And the format of this is class A's IP addressing scheme is the first octet is reserved for the network part. And rest of the 3 octets are reserved for the host part. Host means our computers, our IP addresses, or whatever devices we have. Every device that requires an IP address is a client or a host for us, you can say. So if I say this is a class A address, so if a class A address means if I write a number like this, it is 1.2.3.4, and I say this is a class A address, mean you understand that this first octet is reserved. And for 2 devices to communicate, they must be on the same network. How do you figure out? By this number. The moment we assign an IP address on a device, the device does something called binary ANDing, and it goes and checks in the backend if this is the address, what is my network part and what is my host part. So here I can say, oh, this first octet is the network part. So if this is a PC over here and he wants to communicate to some other PC, but I do not know what network do I belong. So you say, okay, ping 1.3.4.5, for example. So the device checks, okay, the network part is 1. Oh, yes. That means if you want to ping someone, oh, we both are belonging to the same network. Oh, then I will generate a ping request. Now, technically, if you want to go outside your network, in your network adapter, if you see in here, I'll just show you. If you want to cross your network boundary, so if two devices want to communicate, they must be a part of same network. But what if the device is outside your network? What if I say the number you want to ping is, for example, 2.1.1.1? If I say you are 1234 and you want to ping 2.111, then the device says, oh, this device is not on my same LAN segment. I want to communicate with someone who is not on my same segment. Then there is another field that is required. Means then we require a layer 3 device, a router that can allow us to communicate. See, there are many fields. One is the IP address. This will discuss subnet mask, and this is a default gateway. So if we want to go outside our network, we must have a default gateway that is configured. So how does the device, now if I say it is a class A's address, the first octet is reserved for the network part and the 3 octets are reserved for the host part in the class. So how does a device understand that which is my network part, which is the host part? Now technically, seeing the first octet only, there are the numbers we will discuss now. Seeing the first octet, the value inside it, the device automatically figures out that which is my network, which is my host part. Now if you write, if you say 1 2 3 4 like this, how does the device understand which is my network? So that is the reason we have to supply a subnet mask. This value here in the second line is a subnet mask. So if I say 255.0.0.0, this means I am reserving this first octet here for the network. Means this octet is your network and this value will not change. Here any value can be. This is host addresses. Host means any person can have any address. It's like our surname, the last name of our family name. So if this is our last name, this will remain the same, and these are the family members. Family members' names will be changing. So if we are two people and we are in the same surname, we can communicate. If I want to communicate someone outside my my surname, then I require the permission of a router or some other device. Okay, so class A's address is something like this, and the subnet mask is always like this. We'll see how does it understand, because it is generated in a leading bit pattern. I'll show you that. But as of now, class B has the format of network. First 2 octets are reserved for the network and 2 octets are reserved for the host part. Means if I write any number like 1 2 3 4, then I say okay, 255.255. 0.0 means the device understands, oh, this is my network part. And these are any valid IP addresses. These are addresses that anybody can use. So if two devices want to communicate, they must be a part of same network. How do I understand? Okay, by the subnet mask. Now, if we try to assign an address on a PC, how does it automatically understand? I will give 2-3 numbers. Let us see. For example, if I say I have a PC over here and desktop IP configuration, if I say 1 2 3 4, I hit a tab, automatically it populates 255.0.0.0. If I say 130.111, I hit a tab. Why does it say 255.255 over here? It should say one time, right? How does the device understand that this is the network part? Or if I say 200 over here, .111, and I hit the tab, why does the device write 3 times 255 over here? Because the rule says, see the first octet, and then only you automatically come to know which class do you belong to. So where does
But
the
the
device
first
understand?
one is 192.
Yeah, if I say any number, if I say 191 sorry, if I say 191, I hit a tab, it is a class B address. But instead of this, if I say 192.111, see, the three octets are not changing in here. The first octet only decides which class do you belong. See, 192 and 193 has a different value, right? So why what is the feature that tells the device? Now the makers of address made this in a leading bit pattern. We'll discuss that, but as of now, the class C has three octets reserved. So network, 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 and the host. So if I say I have a small network, see, this is this depends on the people, how many devices we require. If you have a requirement of 200 IP addresses, I am talking about IP addresses, means these are addresses we will assign to our hosts. So if I want 200 host, anytime we talk about host, see, from the right to left, like how we write Arabic, like
Yeah,
right
yeah.
from right to left, because I am also a Sindhi, I used to learn Arabic sometimes, so that is why we write alaf and bay, from this side.
Yeah.
So if I have a requirement of host, it's like 2 raised to the power, you say, okay, how many hosts will I get? If I have 8 bits for the host part, I get 256 numbers. But anytime you calculate the host bits, always make sure you minus 2 from that. Why? Because in every network you will have one ID reserved for the network part, and and one ID for the host or for the broadcast part. Means, for example, if I say I have a network that is 192.168.1.0, sorry, we'll say 1.0.0.0.
Mm.
So this 0, if I say these three are the networks, they will remain constant. Here the last octet will be, last number will be 1.0.0.255. For example, we'll take another number, class C range, we'll take 192.168.1.0. Last number will be 192.168.1.255. So this is the network identifier, and this is the broadcast ID. In between these 192.168, if we are using these numbers, 192.168, 1.1, from 1.1 till 1.254, till the last number 254, these numbers will be our valid IP addresses. Right? So this I cannot use, and this I cannot use. So if I want to refer everybody in the same, in this network, the device will send a broadcast. This is the broadcast number for this network. So if I want to do an ARP request to anybody, the request goes out for this number, and everybody has to hear it because they are a part of that network. Okay, so that is the reason we subtract 2 out of any host calculated. So that is how. So how many host addresses will we get in a class B address? We have 16 bits reserved. So 2 raised to the power of 16 is 65535, and we subtract 2 out of it. So if there is a class B address, you have 65533 IP addresses in one network. If I say one network, means the broadcast domain is also very big. Why? Because a broadcast has to be heard by everybody, and if I send a broadcast on this number, it becomes very huge, right?
Yeah.
So if I say it is a class A address, I have 2 raised to the power of 24, and how many IP? 16777 these many numbers I will have for my addresses, and if I subtract 2 out of it, I have so many IP addresses speaking in one network, you can say. So depends on the requirement that we have. It is a small, medium, or large type of design. So you can design your network anyhow. These addresses are fixed. This is called the class full range. Now if I say I have a requirement of 200 addresses, so I can go for this one. 200 addresses is this, right? If I say more than 254 addresses, I can go for class B, right? But if I say class B gives me 65,000 IP addresses, I don't want 65,000 addresses, I want only 1,000 IP addresses. But if I have a party and there are 252, if there are 1,000 people invited and I have to book a hall for 65,000 people only, I don't have a chance. That is not a right decision, right? That is not an optimal decision. That is when we will do some borrowing from the bits, but that we'll see in a few minutes.
Yeah.
Okay, so let us see how does the device calculate what is the network part and what is the subnet part. So these addresses are created in a leading bit pattern. The first bit, the first octet is your leader. 8. Yeah. So this octet is the leader. So they said if you want to know which class do you belong, you will see only in the first octet. And this side is your leading bit, for example. So in the first octet, 0 is the number. So this is the decimal number and this is my decimal value and this is my binary value. So in the first class, they said you will not use this first bit until and unless you don't have space over here. Means you can use any number from 0 and 1, 2, 3, 4, 5, 6, 7, but it comes till 127. So the class A's address should start from, you can say 1 and goes till 127, but there is a catch to it. You cannot use 127 numbers. So you can say the actual range of class A addresses is your 1 to 126. So any number, if you put on the device, it understands that I am a class A address. Let us test it. Let us see. Let's go in here. Sorry. Let us say 1.1.1.1 and hit a tab. Sorry, I added a 0 out of it at the end. See, this guy automatically comes to know, okay, 1 here means it is a class A address. Let's say 126.111. Again, class A, right? So if I say 127.111, it says this is an invalid IP because this 127 number is not usable. That is why I told you there is a special address. Any number starting with 127 in the IP network, you cannot use. Why? Because this whole octet has been reserved for something called loopback purposes. What is a loopback? It is nothing. It is a testing interface. Now, anytime I will go on my command prompt and I can ping any number 127.111, it will give me a reply. And if I ping any number 127, the last number 255, but 254 in here, this will always give me a reply. So you cannot use an IP address starting with the number 127. Now, if I am in a... Sorry?
By this device?
Yeah, I did not get you.
This pinging in the device itself or what?
Yes. This pinging is pinging the network adapter, you can say. Now, why do we want to ping ourselves? Now, if what if you say ping 127 and some number in here and the ping reply does not come up? Anytime we sit for troubleshooting, we always check our device first. So we will ping the network adapter. If the network adapter is working fine, this ping will give us a reply. There are two possibilities. If the network adapter is not working fine or the IP stack is not enabled. Means simple as that, he does not understand what is an IP address. Now this will never happen. Why? Because IP is the king of the network. We are only learning IP. There are multiple different network types also. IP, IPX, Macintosh and all. Novell has its own. So there are other protocols also. But we are learning IP. And IP is everywhere. But several companies will have their own protocol also. So there are two possibilities. If there is, just a second. If the network adapter is not working fine or the IPv4 stack is not, IP stack is not enabled, but this number will always give you a reply. Now, initially, the IP addresses were new, very new, you can say. So they never thought that why to waste. If you see here, the whole octet is reserved. So we are not using this octet anywhere. So you start with a range 127 dot, you can say 0.0.1 and the last number is 127.255.255.254, you can say. These are valid numbers that you can ping. 2 raised to the power of 24, 16777, numbers reserved
For loop back, right?
for loop back, and you cannot use it. So
Okay, okay.
in IPv4, this was the thing, but in IPv6, see, if you want to ping, just a testing interface requires one number only. So why do we use whole network range? In IPv6, they have changed this format. In IPv6, there is only one number reserved for testing purposes, : 1. I'll show you this one also. If you want to test your IPv6, you can say 2 times colon and hit 1. This is a loopback in IP version 6.
Okay.
I'll teach you once we discuss IPv6, then we will discuss about this also. So in IPv4, we have this number that is not usable. In IPv6, there is only one number. So your class A addresses starts from, you can say, the first to 126. And inside, this is the overall range of your public addresses. From this, the number 10 is reserved for private addresses. Means if we have a private network and we want to assign addresses for ourselves, then we will use the number 10. 10 dot anything you can use. This is the network part, and this is what we will use for ourselves. So if I say I have my office and this is your office, and we are connecting with each other on via the internet. So inside in here, I connect from my office to the ISP, and you also connect from yourself to the ISP. So now, what type of addresses are used where? On this outside world, you have the public addresses. And inside our cloud, you can say, here we have the private addresses. So you and me both can use the same number inside. You can use any number starting with 10, and even I can use any number starting with 10. IP addresses, this public range is non-routable. You cannot do routing. You cannot go on the internet using these numbers. So 10 number you will never find outside. Outside in here, you will always find other numbers starting from 1 going to 126, except this number 10. If you assign you have a router, for example, over here. A router will have two interfaces, one going to the outside world and one inside. You can say we will create a network, and so the interface pointing to the internet will have a globally unique address that will be provided by the ISP to us. Inside, now even if, what if, now we also think, what if I assign a private address over here going to the internet? Your ISP will filter that address, because your ISP also has its own private network. There also he can use this number. So for internal purposes, private use, you can use this number. And if you want to go on the internet, you require at least one public address. Okay, now how are we doing our routing? Inside, if you see, we assign ourselves with a private address range. How are we going on the internet? Because there is a router on our edge, you can say, on the edge of our network. He is doing something called translation. We will see what is translation. That is network address translation. So what he does is, he takes our private addresses and he converts them into a public address so that the globe can see, and he can route it accordingly. Clear? Okay, so coming back to our topic, let's see. So the class A's address range has this total, this is the total range, and out of this we have the private addresses reserved. So if I say 10.0.0.0, any number starting with 10 is a private number. The range is 10.255.255.255. And the special address that we saw is 127. We cannot use the number 127, anything from 000 till 255. So this is about class A. Class A has a public range, a private range, and a special. So what about the class B? In class B, the leading bit. Now the leading bit is the first bit in here. If you notice, the first bit was the leader. We were not allowed to use the first bit. Now the leading bit is the second bit. Now we cannot use the second bit, and then we can use any bit over here, 00, 0000. So what is the value above the first bit? If you remember, 1, 2, 1, 2, 4, 8, 16, 32, 64, and 128 is the last number, right? So if I say what is the value above this first bit, it is 128, right?
128.
So the class B's address range starts with 128, and the rule says we cannot use any other bit until and unless we have all the bits utilized. So that is how we come to know, okay, it goes from 128 and starts till 191. So class B's address range, overall range, is from 128 to 191, and that is the reason we said 191, and it takes a class B subnet mask. From the class B, you have a number reserved 172.16.0.0 going towards 172.31.255.255. Means you have 172.16 is one network, 172.17 is another network, 172.18 is another network. So you have 65,000 addresses for one network. Like that you have for 16 networks, you can say. So this again is a private address. So you have an option to use any number starting with 10 if you have a huge enterprise. If you have a small enterprise, you can use 172 number. This is again private. What is a special address in here? There is an address reserved 169.254.x.0.0. You can say 169.254.255.255. Now technically you cannot use any number starting with 169.0.254. Something like this. Why and what purpose? It is known as APIPA. I'll tell you what is APIPA in just a moment. Getting the point? This is an address range that is reserved. Let us see the class C. So if I say, how do we calculate the class C over here? Class C says the third bit is the leading bit, 110. So 0, 0, 0, 0, 0, and in here 1, 1, 1, 1, sorry. So class C says the overall range 128 plus 64. The value above these two bits is 128 and 64. So it equals to 192. Class C's range will start from 192 and goes towards 223. Clear? And in here, the number 192.168.0.0 going towards 192.168.255.255 is reserved. Now technically you have the three octets. This number 192.168 from 0, this is reserved over here. This is the network part, although you will not see a number on the internet. So you can use any number starting with 192.168 and you will not see these numbers on the internet. Here we do not have a special address that is reserved. Just a moment. Yes. So getting the point, class A, class B, and class C. So what will be the subnet mask of our class A? The class A's subnet mask will be 255. I'll write it here, 255.0.0.0. Class B's subnet mask will be 255.255.0.0, and class C's subnet mask is 255.255.0. You're getting it? Class A, class B, class C. There are more classes, class D and class E also, but we are not going to use those because they are reserved for some other purposes. Let us see what are the numbers. I'll just take them out. So if I say the class D, what is, give me a second, I'll just change the color. Yeah, class D, the leading bit will be 111 and 0, and then 0000. So this comes to 224. 192 plus 64 plus 32 is 224, and this range goes towards till 1110 and 1111. So your class D's range starts from 224, goes till 239. And this range is not used by us because this is reserved for something called multicasting. multicast purposes. So even if we try to assign this address on our network adapter, it will not accept. Your adapter will clearly say, please assign an IP address from the value 1 till 223, because we can only use class A, class B, class C numbers. Let us see. If I say there is one more class, class E. Class E has the number reserved. So leading bit here will be 11110 000. So the number comes till 240, you can say, and it goes till 1111 1111. It is last number 255. So this is the overall range. Class E addresses are reserved for research and development purposes. So we have our class A, class B, and class C, class D addresses, and class E addresses. This is the overall range, out of which every range has its own usage purpose, you can see. So we have an option to use. Now we are not going to use public addresses. We will always use private address range for our internal purposes. So we should make ourselves familiar with three numbers, that is 10 dot something something something, 172.16 dot anything till 172.31 any number, and the third is 192.168.x.x. Here these three bits are reserved, the three octets are reserved for the network part. So just an example, 192.168.0.1 is a valid address. 0.0 is the first network. If I change this, 1.0 is second network, 2.0 is third network, 3.0 is another network, 4.0 is another network. So you can have 255 networks like this, you can say 56 technically. So we can use this number for our daily purposes. That is the reason we often use this number. We see this number on a daily day-to-day basis, 192.168. Getting the concept clear, easy?
Yeah.
Okay. Now, where did this APIPA and what is this APIPA used for? Now, there are two ways of assigning an IP address. If we open our device over here, if you want to assign an IP address, you say static assignment, means I will manually assign an IP address. But if I say I have 1,000 PCs and every day I cannot troubleshoot, because troubleshooting becomes very difficult when it comes to manual stuff. That is why we are moving to automation in our cloud and all these days. We have UCS, ACI, API controllers. But simply earlier also they had an issue. If I have hundreds of PCs daily changing the IP addresses, there are lots of conflicts. So we need some automated way for IP address assignment. That is where when DHCP comes into picture. DHCP is Dynamic Host Configuration Protocol. So any server that provides us with a DHCP service will become our DHCP server. For example, if I have a server over here, a server provides services and a client will receive the services. So if a server is providing me HTTP service, it becomes my web server, you can say. If he is providing me DNS service, he becomes a DNS server. If he gives me TFT, DHCP, yeah, DHCP. So if he is providing me IP addresses automatically, he is my DHCP server. So instead of us manually assigning IP addresses, we have Microsoft DHCP servers also. We can also create a router to act as a DHCP server. We will do that in a day or two maybe. So what happens? See, I'll show you just in a moment. What we can do is just simulate in a second. We can say this guy requires an IP address. And you can simply say services DHCP. Turn the service on. Pool Cisco Default Gateway 1.1.1.1. DNS server, I'll give root DNS server, I'll give start IP 1 and IP. I want only 100 addresses and save these addresses. Let us see whether he is able to get an IP address from there. See, DHCP request was successful. I got an address automatically. So in the back end, what if, see, for example, if I turn this link off, if I cut the cable from here, and then again, now this is a leasing system. If I say go request the DHCP server, he's searching for a DHCP server. He's doing the DHCP discover in the backend. Now, technically, there is no DHCP server. So what will happen here? Now, he does not have a static address. He does not have a DHCP received address. Where will he go? In this time, he will assign itself an IP address with the range from 169.254. That is automatic private IP address assignment. Because the DHCP is not present. If the DHCP was there, then he could have assigned himself with an IP address. But in this moment, if I try to check my IP address, I will not have an address, but on real devices, you will see 169.254. Automatic private IP address assignment. I'll take another device, maybe. No, but I'll show it to you well once we are doing the practical on real devices also. So what happens once you go out and request the DHCP server? But there, if you say if you tell your device to go outside and get the IP address from the DHCP, there is a process called DORA process. It is the DHCP discover. DORA is discover, offer, request, and acknowledge. So who does what all these things? So this is a PC he wants, and this is the DHCP server he wants. And so DHCP server will have a pool of IP addresses. For example, I say 1 to 100. I told him how many addresses I want to distribute. So he said, okay, 1 to 100 addresses I want to distribute. Okay. So this is a PC who is sitting in here, and we as admins, we say, okay, go out and find the DHCP and get the address form for yourself. So he does this first. In this moment of time, I don't have an IP address. I use 0.0.0.0 as a source address. 0.0.0.0 as a source address. And I do the DHCP discover. The DHCP, now this is unique, this is broadcast, and I'll show you all the packet level details in here. We will see what happens in the packet. We will capture the DHCP packets. So discover is done by the start end host. DHCP gets the request. This is a broadcast, and it is received by the DHCP. DHCP has a pool. He gives us an offer. So he says, okay, you can take 2 as the IP address. So he gives us an offer. Okay, we say, okay, can I take this 2 address? This is the request packet. Okay, can I take 2? He says, go ahead and keep it for yourself. This is your address. Now, why is this a 4-step process? It can be discover and offer, right? I call for a discover, he gives me an offer. But technically, what does the DHCP do? When he gives us an offer, when he says, okay, take this address, after that, in the back end, he pings that address to and checks whether someone already has that address. Maybe there is a PC over here. There is a new person who knows a little bit about IP addressing, and he automatically assigns himself with an address of 2. So this guy will reply. He says, I have the address, right? DHCP received a request. So he will say, okay, I will not allow you to take the address of 2 because there will be an IP address conflict. So you can say, okay, no, I will not say act to your request. Take another address 3. And then, okay, then I will say, can I take 3? He will say, yes, go ahead and take 3 as your. So discover, offer, request, and acknowledge. So DHCP makes sure that these addresses are not overlapping. There will be no IP address conflict. If there is a conflict, he will take out this address from his pool, and until and unless the administrator does not say, he will not allocate the address to anybody else. Okay, getting it?
Yeah.
Discover, offer, request, acknowledge. So what if my device has been configured to go out and get the address from the DHCP server, and the DHCP server is not available? So my device assigns itself an IP address from 169.254 dot something something range. That is when APIPA is used. Okay, and if you see this address is also known as the link local address. You cannot go out on the internet. Over here, if you notice, you will see a warning sign like this in yellow, and he will say, okay, I don't have an IP address, we cannot go on the internet. In yellow you can see that. Okay, now, so discover of a request, acknowledge, and APIPA DORA process. Let us see if two devices want to communicate. Let us see the subnet masks. See, PC here, PC here, switch from here. We can assign them an IP address with 192.1. So I'll say 1.1.1.1 simple address. See, 1 is the network part now, right?
Yeah.
And here I will say 1 dot any number. So my device does the binary ANDing. He knows, okay, 1 is the network, the rest all are the host addresses. Let us see, can I ping him? Can I am 1222. Can I ping 1.1.1.1? Yes, I can ping him because we are a part of same network segment. If I change this device from 1 to 2, now this PC is, he says, okay, for me to communicate with someone, now he checks, okay, what is my address? My address is starting with 1 and his address is 2. So he will not even generate a request packet. Technically, I'll show you when we are doing switching. This device does not even generate a ping packet because he checks the default gateway and he says, oh, if I want to cross my network boundary, I need to consult the default gateway. And if I have a default gateway, I will send it to him. If I don't have a default gateway, I will not even bother to send a request. Let me show it to you. Once we are doing port security, I will be able to show you, show MAC address table. And here he is learning the addresses. If I flush the addresses, you will see that this person will not even send a request over here. We'll do in security related part. Okay, now a little bit, let's go in a little depth. Let's see what exactly happens. We will capture some packets. We will see what is the DORA process and what are the packet formats in just a moment. So if I say no, for that, I will have to do some DHCP configuration. Okay, just remind me, once we are doing, once you know routing, and we will create a router as a DHCP server. And I will be able to show you how the request is going to be passed. What we can do is, we can connect these devices in this fashion from here to here. And I will make this device as a DHCP server, and I will ask this router to take the address of this interface from the DHCP, and then we can capture the packets from here. So if I say start capture and capture the packets in Wireshark. So this is a very nice tool, very handy tool, and it's open source, you can say. This tool is openly available. So if you want to learn more about packets, what exactly is going on in the backend, we will see. If you want, give me just 2 minutes, I'll show it. We'll stop this capture and we'll say stop capture. As of now, no packets are being captured. Stop Wireshark. I can turn them on. R1 and R2. What we can say is, just a moment. IP DHCP pool, NH, network, dot 1.1.1.0.0.0 default router 1.1.1.1. Okay, exit. Now what I'll do is I have just created a DHCP server over here, and I will go on router 1. Router 1, router 1 has one interface that is off. So I can, there are multiple ways of assigning an IP address on a router's interface. What I can say is, I'll just start capturing and we'll see Wireshark. Yes, okay. So we'll go back on that one and I'll say configure terminal. IP address for this interface will be assigned by the DHCP. Let me check whether it is working. Yeah. And I'll say turn this one on. Let us see what happens. DHCP discover, offer, request and acknowledge. Right? Let us stop the capture. See, it says assigned DHCP 1001. Mask is this, host name is R1. I can say show IP interface brief. Earlier, this interface does not have an address, right? F00, right? Now if I check again, now this has an address. It is assigned by the DHCP server. I'll just turn this off. Yes, and let us see DHCP discover. So if you want to learn more about DHCP or anything related to, you can say networking as of now, Wireshark is the best place to learn. Here I'll tell you what is this. This is a layer 1 stuff that is not for us, you can say. This is a layer 2 stuff. Layer 2 in the OSI reference model is Ethernet layer. Here you will have the MAC addresses, data link layer, the MAC addresses. See, the destination is a broadcast. It is for everybody on the segment. The source is the source interface's address, source MAC address of the PC, you can say. Just assuming that this device over here is not a router. This device is a PC, for example. Assuming that this is a PC and he went out to a DHCP server and he got a request from there. So this is the source address of the PC and this is the address. Just note one thing down if you're writing. This is a UDP, user datagram protocol. This uses UDP and see the source IP address 0000 in here. And destination is 255.255.255. So 0.0.0.0 is reserved for DHCP discover and we cannot use this number. And destination all means it is for everybody. Source is 68 and destination port is 67. So you can say when I talk on the port number 68 here and the DHCP server will listen on 67. Once he talks, he will talk again on 67 and I will listen on 68. Let's see once the packet receives. Let's see that. So if you are noting it down, this is very important from interview perspective. What type of packets is a DHCP packet? DHCP discover is all the packets are technically user datagram protocol UDP packets with the source 68 and two ports you can say 67 and 68. So in here source destination bootstrap protocol, inside all the terms will be discussed and here see it will say discover message and this is discover message. Let us see the offer packet. The offer packet is, see now, earlier I was talking on 68 and he was listening. Now he is talking. So he talks on 67. I listen on 68. So the host will use 68 and the server will use 67, you can say. Because this is the source, this is the server talking. He is talking on 67 and I am listening on 68. Again, this source is from him and destination is again for everybody. See, the source is 11 and destination for everybody. So this is again a UDP packet and it is sent like this. What is inside? It is the offer packet, you can say. What offer is he giving me? See this, your client IP, he gives me an offer 1001.
Okay.
And request and acknowledge. If I see again UDP, this is me on 68, he's on 67. Request packet. Again, this is also a UDP and this is sent on the broadcast. Still broadcast is going on. And if I see the final packet inside, this will be an acknowledgement packet. Still, this is also a broadcast packet with UDP. Clear, getting the point?
Yeah.
Okay. For learning purposes, this is a very nice software. Wireshark is very useful. There is also a global certification related to Wireshark. It's for $295. You can do it in Pearson VUE like Cisco only. Same like that. It's in packet level details. Okay. It's 8 o'clock. Do you want to take a break?